Hi, I'm Sayed on Maths Online. Today we'll be dealing with the topic of differential equation. So under differential equation, I'm taking up the linear differential equation. Linear differential equation of second and higher order with constant coefficients. So let us try to consider the differential equation. We'll try to consider the differential equation of the form, say d power of ny by dx power of n plus a1 d power of n minus 1y by dx power of n minus of 1 plus a2 d power of n minus of 2y by dx power of n minus of 2. It goes on. We try to continue. It's a1, a2, a3, a4, a5 and so on. Say a n minus of 1 dy by dx plus a n y is equals to 5 of x. So I have considered the linear differential equation, right? So here I am considering the nth order derivative, and the coefficient of this is a constant. Its coefficient is 1. So therefore I am considering the constant coefficient over here. So what are these values? a1, a2, a3 and so on, all these are constants. So a1, a2, a3 and so on, an are all constants. They are just the constants. So now I can rewrite this value. Say suppose if I take the value of d by dx to be, say, capital D. So capital D is written as d by dx. So this capital D will represent the differential operator. So this capital D is called as a differential operator. So where this d represents d by dx. Similarly, if I try to rewrite d square, so this will represent d square by dx square. And similarly, if I write d cube, it will represent d cube by dx cube and so on. Suppose if I write d power of n, so d power of n will be d power of n by dx power of n. So if I try to plug in those values here, so if you try to observe here, d power of n by dx power of n can be written as d power of n. Therefore this differential equation can be written as d power of n, and this y will remain as it is, plus here a1, this can be written as d power of n minus of 1 into y, and here it is a2, this can be written as d power of n minus 2 times of y and so on, plus it is an minus of 1. D by dx can be written as d times of y plus any is equals to 5 of x. So if you try to observe in this entire equation, y can be taken common outside. So if you take y common, you will be left out with d power of n here plus a1 d power of n minus of 1 plus a2 d power of n minus of 2 and so on. Here it is n minus of 1 d plus an. I am taking y common there for all these terms is equals to, you have 5 of x. Now this complete expression can be written in the form of f of d, because this expression is in terms of the differential operator capital D. Therefore I can write the function of d times of this y is equals to, you have 5 of x. So in general, you can write down the differential equation in this form. F of d times of y to be equals to 5 of x. Suppose if I take 5 of x to be equals to 0, then this differential equation can be written in the form of f of d times of y to be equals to 0. So if the right hand side value is 0, then this differential equation will be called as the homogeneous equation. This equation is called as homogeneous equation. Suppose if the value of this 5 of x is not equals to 0, then you can write f of d times of y is equals to this 5 of x. If phi of x is not equals to 0, then such type of equations are called as non-homogeneous differential equation. Non-homogeneous equations or non-homogeneous differential equations. So these are the two types of differential equations we have. Now let us first try to discuss about the homogeneous equations. So let us write down the solution of homogeneous differential equation. Since we are discussing about linear differential equation, let us write down solution of homogeneous linear differential equation. Linear differential equation. We know that if phi of x is 0, then such type of equation will be called as homogeneous differential equation. So what we'll try to do is, instead of taking the general equation, I'll try to take the second order differential equation. Suppose if I consider the second order differential equation of the form, say d square y by dx square plus a1 times of dy by dx plus a2 times of y is equals, right hand side should be 0, then we say it is a homogeneous equation. So I have considered the second order differential equation where this a1 and a2 are constants. So where a1 and a2 are constants. a1 and a2 are constants. So if you want to write down in terms of the operator capital D, then you can write this as d square by dx square will be d square of y plus this will be a1, d by dx of y will be dy plus you have a2y is equals to 0. Or if I take the value of y common outside, you have d square plus a1 d plus a2 times of y is equals to 0. So it is a second order differential equation, or because this is in terms of the operator, differential operator capital D, I can write this expression of f of d times of y is equals to 0. So this is a homogeneous linear differential equation. So how to find out the solution of this homogeneous linear differential equation? So the solution of this linear differential equation can be written as y is equals to CF. The solution will be the complementary function. So this CF represents the complementary function. Complementary function. So if you are able to find out the complementary function, then the solution of this homogeneous equation will be the complementary function itself. So how to find out the complementary function? So let us try to see the method of finding out the complementary function. So we have this homogeneous differential equation. So what does this f of d represents here? F of d represents your operator d square plus a1d plus a2. Now from this f of d, we will try to form the auxiliary equation. Auxiliary equation. So in short, from now on I will be using AE. So AE will represent the auxiliary equation. So we'll try to form the auxiliary equation for this f of d. So I'll replace this d value by m value. F of m is equals to 0. So I'll form an equation of this form. Just replace wherever d is there, replace that by m. Equate that to 0. And solve this quadratic equation, because if it is of second order, then in that case you can solve the quadratic equation. Suppose if it is of third order, then you can solve the cubic equation. So in that case you can just solve the equation and try to obtain the roots of the equation. So because it is a quadratic equation over here, you can find out the two roots. So solve the equation to obtain the roots. So what will be the roots? Because it is a quadratic equation, you might get, because it is a quadratic equation, you will get m1, m2. I'm just taking a case of quadratic equation. So if it is a cubic equation, in that way you can solve for 3 roots. So I'm just taking an example of a quadratic equation. So in this case you will be getting 2 roots, m1 and m2. Now these 2 roots, how can these 2 roots be? So this m1 and m2, these 2 roots can either be real and distinct. It can be real and distinct root. Then m1 and m2 can be real and equal roots. And the third case can be the complex roots. So this m1 and m2 can either be real and distinct roots, m1 and m2 can be real and equal roots, m1 and m2 can be complex roots. So if it is real and distinct, what will be the solution of the differential equation? If it is real and equal, then what will be the solution of the differential equation? If it is a complex roots, then what will be the root of the differential equation? So let us take these 3 cases. So let me start with case number 1. Case 1, if the roots are real and distinct. So let us try to take if roots are real and distinct. Real and distinct. If the roots are real and distinct, then how to write down the solution? So I'll take an example of a quadratic equation itself. The same thing can be extended for higher order. So if the roots are real and distinct, so you have 2 roots m1 and m2, they are real and distinct. Distinct means they are not equal. So m1 is not equals to m2. Both the roots are different roots. So because they are different roots, we call it as distinct roots. And it is a real root. Right? So if it is a real root, in that case, we write down the complementary function to be equals to. So I am writing in short CF, complementary function. So because there are 2 roots, m1 and m2, so I write down the complementary function to be equals to c1 e power of. The first root is m1, so we write m1x. The second root is m2, we write c2 e power of m2x. So this will be the complementary function. So this complementary function itself will be the solution for the homogeneous differential equation. So whenever the roots are real and distinct, this is how you write down the complementary function. Let us go for case number 2. This one, if roots are real and equal. So roots m1 and m2 are real, but they are equal. That means both are equal. And m1 and m2 are equal. So the roots can be 2, 2, they are the same, or 3, 3, or minus 2, minus 2. So both are equal. So let me take that value to be, say, m. Both are equal to, say, m. Then what will be the complementary function? So the complementary function can be written in the form of, because they are equal, we write it as c1 plus c2x into e power of. m1 and m2 are equals to m. So m times of x. So that will be the complementary function for real and equal roots. So let us take case number 3. If the roots are complex. If roots are complex. If the roots are complex, how to write down the complementary function? So here the roots are complex roots. So complex roots always occur in pair. So suppose if I take these two roots m1 and m2, these two roots m1 and m2 are complex roots. They occur in pair. So therefore if I take the roots to be alpha plus or minus I times of beta. So suppose if I take the complex roots to be alpha plus or minus I times of beta. So which means m1 value will be alpha plus I beta. m2 value will be alpha minus I beta. These are the roots. So they are in pairs. So if they are complex roots, how to write down the complementary function? So the complementary function can be written as e power of the real term alpha. We write alpha times of x into, it is c1 cos of, I will take the imaginary term beta. So beta times of x plus c2 sine of beta times of x. So this is how you can write down the complementary function if the roots are complex roots. So let us take few basic examples and try to check how to write down the complementary function. So first I will just take how to write down the complementary function, then we'll go for the problems. Alright, so let us take some basic examples. So let me take, suppose if the roots, I'm just giving m1 to be equals to say 3, m2 to be equals to say 5. So these are the roots. How to write down the complementary function? First we need to check whether these roots belong to case 1, case 2 or case 3. So two roots are there. They are real numbers. 3 and 5 are real numbers. Therefore, and real numbers, and they are different. That means they are distinct. So that is if the roots are real and distinct. m1 and m2 are not equal. So how to write down the complementary function? So the complementary function can be written as c1 e power of m1. So what is m1 value here? 3. So 3 times of x plus c2 e power of m2. m2 will be 5 times of x. So this is how you can write down the complementary function. Now suppose for example if I take the roots to be, roots are say 1 comma minus 2 comma 3. 3 roots I have taken. So once again you try to check. 3 roots means for cubic equation you get 3 roots. So the example that I have shown you here is for only the quadratic equation. Even if you can extend the same formulas if it is a cubic equation or higher order equation, you can use it. Now all the 3 roots are different, therefore they are real and distinct. So if you write down the complementary function for this one, so you can write down first one c1 e power of m1. m1 is the first root is 1, so 1 times of x plus c2 e power of second root. Second root is minus 2 times of x. So if only 2 roots are there, you will stop it over here. But you are having the third root also. So therefore you have to extend that one. So I have written already c1, c2. I will extend that to c3 e power of. What is the root you have? 3. So 3 times of x. So if you have 4 roots, once again you write c4 into e power of. So in that way you can extend this formula for any higher order differential equation. So we have got the complementary function for the first case. Now suppose if I take the roots are 2 comma 2. So which case this root belongs? 2 comma 2 I have taken, which means that both the roots are the same. m1 and m2 are equals to, so this is your m1 value, this is your m2 value, and both are equals to m, right? That is 2. They are equals to 2. So in that case, how to write down the complementary function? So it is C1 plus C2x. This is how you write. C1 plus C2x into e power of m. M value is what? 2. So 2 times of x. So this is the second case. If the roots are real and equal, you write down the complementary function in this form. Similarly, suppose if I take the roots are, say 3, 3, 3. So 3 roots are there and all the 3 roots are equal. So how to write down the complementary function? The complementary function can be written as the same way you have tried, C1 plus C2x. So 2 constants I have written for 2 roots, but here 3 roots are there. You have to write down third constant also, C3. So here x is there. The next term when you write it becomes x square. Right? So it will be in the increasing orders of x. First is C1 into 1, then x, then x square, then it will be x cube and so on. Because here 3 roots are there, you get C1, C2 and C3. Into, you write e power of, what do you have the root as? 3, so 3x. So in the same way, suppose if I take the roots are, say 5, 5, 5, 5. 4 roots I am taking. And all the 4 roots are equal. So therefore, you can write down the complementary function as, so the same thing you have to express, that is C1, C2, x, C3, x square. Right? So how many roots are there? 1, 2, 3, 4. 4 roots means 4 constants you have to get. C4. Here you can see x, x square, the power increases, x cube. If there is one more root, it becomes C5, x power of 4 and so on. So it is e power of. So what is the root here? 5. So it is 5 times of x. So in that way you can go on extending depending upon the number of roots. This is nothing but your case 2. Now let us take the roots. Roots are, suppose I am taking the complex roots, say 2 plus r minus 3i. Complex roots, which is nothing but this is in the form of alpha plus r minus I times of beta. So here beta value is 3. So how to write down the complementary function? So I told you it is e power of alpha x. So alpha value is what? 2. So 2 times of x into, it is C1 cos of beta. Beta value is 3. C1 cos of 3x plus C2 sine of 3x. That is how you can write down the complementary function for case number 3. And they are complex roots. So let us take another example. Roots are minus 1 plus r minus 2i. So once again you can check over here, the value of alpha is minus 1. Your value of beta is 2. So how do you write down the complementary function? The complementary function will be e power of alpha x. Alpha value is how much? Minus 1. Minus 1 times of x into C1 cos of beta. So beta value is 2x plus C2 sine of beta x. 2 times of x. This is how you can write down the complementary function when the roots are complex. Suppose if the roots are in this form, say minus 2 plus r minus 3i, they are repeated. So minus 2 plus r minus 3i. So the complex roots are repeated, where the value of alpha is minus 2, the value of beta is 3. So they are repeated, then you have to go for this type of case, C1 plus C2x, whenever they are repeated. So here the complex roots are repeated how many times? 2 times. Therefore 2 constants will be getting C1 plus C2x form. So if you try to write down the complementary function for this, complementary function will be equals to e power of alpha x. Alpha value is how much? Minus 2. So minus 2 times of x. Now because the roots are repeated twice over here, so when you are writing the constant, it will be C1 plus C2x. C1 plus C2x if the roots are repeated twice. Suppose if the roots are repeated thrice, you write C1 plus C2x plus C3 x square in that way. So into So the first term will become cos. So cos of beta. Beta value is how much? 3x. Similar to this one, in place of this constant, I am writing the value as c1 plus c2x because they are repeated twice. Then plus. So c2 sign I have to get. So in place of this c2, once again I will be writing in this form. So I have already written c1 and c2. I will use the constant c3 plus c4x into sine of 3x. Suppose if the same root is repeated thrice, third time, minus 2 plus or minus 3i, you will be writing c1 plus c2x plus c3x square. Here it becomes c4 plus c5x plus c6x square. So in that way you can write down. So this is how you can write down for the complex roots when they are repeated. Now let us try to take few examples where if the cases are mixed up, if case 1, case 2 is mixed up, case 2, case 3 is mixed up, and case 3, case 1 is mixed up, in that case how to write down. So the roots are, suppose if I am taking the roots as 0, right, 0, 1, and you are having say 2, 2. So 4 roots are there. So how to write down the complementary function? So first root, these two roots are say real and distinct, case 1 roots. So it is c1 e power of, here m1 value is 0, so 0 times of x, plus you have c2 e power of 1 times of x. Here 2 and 2 they are repeated roots, therefore we will be writing, because I have already used c1, c2, I will be writing c3 plus c4x. If the roots are repeated, in this way you have write e power of how much? 2x. So these are the roots when case 1 and case 2 are combined. And here if you want, you can write e power of 0. So e power of 0 will become 1. So you can write this as c1 plus. So whenever you have 0, you can just write down the constant. Alright. So c1, this will become c2 e power of x. So this value will be as it is, c3 plus c4x into e power of 2x. So this is how you can write down. Suppose if the roots are 1, minus 3 plus or minus 5i. So real and the complex roots are mixed up. So how to write down the complementary function? So here 1 is the real root, so it is case 1. So accordingly you can write c1 e power of 1 times of x. Now it is a complex root, so accordingly for a complex root, this is your alpha value and this is your beta value. So it is e power of alpha x minus 3x into, it is c1 cos beta. c1 I have already used the constant, so therefore I will be using c2 cos of beta. Beta value is 5x plus c3 sine of 5x. So this is how you can write down. So if the roots are mixed up also, you have to write it in this way. So these are a few of the basic examples that we have discussed. So that's all I have for today. Thank you.